Welcome to 3D Learning Lab, where learning comes alive in stunning 3D. Today, we're diving into the heart of one of nature's most powerful forces, the tropical cyclone. Get ready to experience every swirling wind, every towering wave, and the eye of the storm itself in a way you've never seen before. So buckle up, because this is going to be a wild ride through the science behind cyclones, all in immersive 3D.
Tropical cyclones are amongst the most destructive weather phenomena. They form exclusively over tropical seas and oceans, usually between 10 and 20 degrees latitude. Each year, around 50 tropical cyclones form on the Earth, from May to November in the Northern Hemisphere, and from November to May in the Southern Hemisphere. Their names are assigned in alphabetical order. Previously, they were only given female names, but nowadays, male names are also used. One of the best-known recent tropical cyclones was Hurricane Katrina, which brought devastating damage to the city of New Orleans in 2005. A tropical cyclone is a rapidly rotating, strong wind system characterized by an extremely low-pressure center. A tropical cyclone is made up of spiral bands, or a spiral of clouds. The density of these clouds is the highest around the eye, where the converging spiral bands meet. Tropical cyclones not only spin above one spot, but also move westward. Although the wind is very intense inside cyclones, their progress is relatively slow. In the tropical zone, sea surface temperature is highest in late summer. Warm water evaporates, rises, and transfers some of its energy to the atmosphere, thus forming thunderstorms. The wind blowing from the inside of the thunderstorm gathers air, forming an even larger thunderstorm cluster. As the cluster grows in size, it can gather air from further areas as well. Due to the Coriolis effect caused by the Earth's rotation, the air gathered starts to swirl. As a result of the swirling motion, air pressure drops in the center of the thunderstorm. If the cluster lasts long enough, the swirling motion becomes faster, and a thick cloud layer forms around the center. Then, the eye of the cyclone appears as well. This is when the cyclone becomes fully developed. Above the ocean, the lower layer of the atmosphere warms up and then rises. The rising air causes a low-pressure area to develop at surface level. Air spirals inward anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere due to the Coriolis effect. The air rising in the center of the cyclone spreads horizontally in the troposphere. Since this rising air is warmer than its surroundings, the cold air descends in the center, and a cloud-free area, known as the eye of the cyclone, is formed. Tropical cyclones can travel thousands of kilometers from their area of formation before they die out. These cyclones can last several weeks. The life cycle of cyclones depends on how long they stay over warm waters. At the end of the first week, tropical cyclones are called tropical depressions, while at the end of the second week, they turn into tropical storms. Usually, they become fully developed within 10 to 15 days. As tropical cyclones gain their energy from the heat of seawater, they lose their strength very rapidly when they reach the mainland, although they can still cause heavy rainfall. When they leave the tropical zone and enter the area of westerly winds, they lose more energy. However, they can remain in that particular area as a tropical storm for several days. Cyclones can be categorized according to their intensity. However, there is no standard classification throughout the world, as different scales exist based on the area of formation. For example, cyclones formed above the Atlantic Ocean can be classified into 5 categories, based on the speed of the wind blowing in the eye wall. The flow is most intensive in the eye wall, so this is the most destructive part of the cyclone. These devastating cyclones produce heavy precipitation. The amount of rainfall can rise to 500 millimeters a day. Because of their rotation, they can even raise ocean levels, causing floods along the coastline and thereby enormous damage.
That was an epic journey into the heart of a tropical cyclone. We hope you learned something new today. If you loved this video, don't forget to hit that like button and share this mind-blowing experience with your friends. Got thoughts or questions about cyclones? Drop them in the comments below. And of course, subscribe to 3D Learning Lab and hit the notification bell so you never miss out on our next immersive adventure. See you soon, fellow learners.